Thank you for putting up with our little technical fun there. So we're going to be talking about navigation, and that means the new navigation controller that is part of Jetpack. Now, how many people have played with the navigation controller? A show of hands. OK, well, that's great. So we're going to talk about how to do a couple of fun things. Now, we actually wrote the navigation controller because there were kind of two problems. One is that we saw that people were really struggling to actually make navigation patterns work properly in their application. It was, things like fragment transitions were kind of hard and painful, and they didn't understand how to pass arguments between things. And the other thing is that it was really inconsistent for users, the actual experience at the end. So we decided to come up with these principles of navigation. One thing is that that apps have this concept of a fixed starting destination. And let's see if I actually can get this to work. That's not going to work. And so basically the idea, this is the screen that you get to when you are first launching the app. It's that first experience, and it's the last screen that the user should see when they return to the launcher. And this is, that's almost always true, because if your app has some one-time setup or some sort of login, that doesn't count as a start destination. We'll cover that a little later. And then, of course, the thing that everyone wants to know, whether you're a user or a developer, is what actually is the difference between up and back. And so we decided to actually try to redefine that a little bit. Because the original idea of up was that it would traverse up the hierarchy. And that allows someone to travel up to the next hierarchical destination, rather than moving within the fragment backstack, which in theory could be huge. You could imagine Gmail existing, and if you clicked on every single message it actually added to the backstack, it might be really cool to be able to actually hit the up button and get out of there really quickly. But the challenge with that is that, ultimately, these buttons really don't look very different to a user. They really don't understand that that button actually does something functionally different than the other button. And then the other problem is that these buttons actually look the same to a developer as well. So this led to a lot of confusion, as a lot of developers basically ended up not really understanding how to implement this, especially when you get into things like apps that have a fragment-based interface. We kind of defined it for multiple activities. So it really was difficult to be consistent across apps, and it turns out it's not. So we basically got rid of that navigate up the hierarchy thing. In almost all cases, these buttons actually should now have the same behavior whenever they are on the screen together, as long as they are running in your task. Which means that there is a case where they don't have the same behavior, which basically means if you have the ability of a user launching your application from another application, then they actually aren't the same. Then up will actually traverse up the hierarchy, up basically back to the start destination with navigation, while the back key will actually take you out of the app and back to where you were. Since this is not actually that common for real apps, I'm just mostly mentioning this to point out that there is still a slight difference. But for most cases, it'll be the same. Also, if you're at the start destination, the up button disappears because it still can't be used to navigate out of your app. And that's it, basically. That's all you have to do now. Another issue that we ran into was deep linking. And what does that actually mean from a user experience perspective? So the idea is you should always be able to navigate back up to the start destination. And that allows you to get to the rest of the application, which is kind of nice. And my counterexample to this is if you're using Google Calendar, and you get a notification, and it pops up. You can see it actually pops up as a dialog. But there's actually no way to get back and see the rest of your calendar. I don't know, has any of you ever been frustrated by the fact that a notification like this doesn't actually allow you? All right, one person, two people. All right, that's good. It frustrates me. It would be much nicer if it actually just had a little up button there, and it would take you back to the main calendar view. Ideally, it might even work differently than our navigation pattern. But the way it works ultimately means you have to, exit out of this notification, go back to the app, click it, and then go to your calendar view if you want to see other events. But the overriding principle of all this kind of thing is that we want all these apps to be more consistent and that we want the behavior to be really expected by users, so that ultimately they aren't trying to question how the app is going to work, at least in terms of this basic UI. All right, so let's take a quick look at the navigation component now that I've talked about a little bit what we were trying to achieve. There's a bunch of libraries here. really not important other than the fact that there's actually a plugin as well as a main library. So and we also have a KTX version of all of these. So if you're using Kotlin, just use the KTX version. You get all the other stuff included with it, and you get a couple of nice extensions. Note that if you are paying close attention, this is technically part of Jetpack, but it actually does not have an Android X extension on it. And the reason why is we wanted people who hadn't yet migrated to Android X to be able to really easily use this library. So if you look at it, it actually has the class path for Android X, and that's what all of its classes are named as. But it's actually still, as of now, not technically requiring the dependencies of Android X. So you can use it in your app today without having to migrate. How many of you have actually migrated to Android X, by the way? Nice. OK. Yeah, you'll probably, more of you will want to do that eventually. So to use navigation, you'll need a navigation resource. And this is an XML file that can be visualized as a navigation graph and a layout element known as the nav host fragment. And you'll usually add this to an activity layout file. And then this ultimately gives you access to the nav controller, which is what you use to actually control all of this. So looking at the graph, all of these things are destinations. And that's really just the contents of your app. And then the connections with them are called actions. And those are represented by all of those arrows. And those really show you the paths that a user can take. But they don't actually cause navigation to occur when a control is pressed. There's no way to take that arrow and connect it to a button, or you can kind of connect it to a menu, sort of, but not really. So these things are just kind of possible paths. And the nav host fragment itself is actually just a host for other fragments. So it's a fragment that hosts fragments, and typically starting with the start destination. And the nav controller is also used to change the destination that it's hosted by that fragment. So again, it does all the fragment transactions for you. It automatically changes the one that is sitting there, and it'll also help manage the backstack for you in a couple of different ways. You can navigate directly to a destination by using its ID. That totally avoids all those arrows. So you can go anywhere you want. You can also navigate from one destination to another using the ID of an action, which includes those arrows. And that's kind of how you really should use it. Like the fact that we allow you to navigate by an ID is more of an artifact of implementation. But it's really better to actually use those arrows, because then you can actually visualize all those paths. And that's kind of important. It's really one of the things that people have been wanting. Like, when you went to an Android app, you were like, how do I actually get from this screen to this screen? There was no way to see it in the tooling. So part of the idea was to actually make this visible. So secondly, we wanted to define the navigation in one place. Typically, navigation in an Android app was scattered all over these UI files. And that, again, made it really difficult to build tooling that actually showed how all of these navigations occurred. And then we also took the advantage of being able to do things which you can't read here. But on the left-hand side, basically all that stuff includes things like being able to deal with animations and transitions and all sorts of fun stuff. And that allows us to reduce boilerplate for a lot of these patterns. So one of the things we also did is we actually built a UI library that works with this. So you don't actually have to do all of these things that are on the left that you can't read anyways, that actually allow you to implement something like a nav drawer. So look, those are all of the steps. Trust me, those are. And basically, now you can just, a couple lines of code, you get all of the basic navigation things that the design library will give you. And the other thing is that we really wanted to follow the material guidelines for navigation. And this is important because, again, we want to make the experience consistent for the user. This is particularly with respect to the backstack. And if you haven't used this before, and I'm glad a lot of you have, I definitely recommend checking out the Code Lab. I'll mention this again at the end, but it's pretty cool. All right. So the first topic I want to talk about is the difference between an activity or a fragment and destination. Now, thus far, I've been showing graphs that have solely fragment destinations. But it is possible to actually use these for activities. And here's an example of an activity in a nav graph. And you can see here that you can connect stuff to it, but it is a terminal destination. And activities can contain nav host fragments, which in turn can have their own nav graphs. But it's a completely different navigation map. So when you do use it in this way, you end up giving up a lot of the advantage of having navigation in the first place. So a way to think about activities is that basically they contain the nav host fragment, and they also contain like global navigation widgets. Things like bottom nav, app drawers, all of those things. And the fragments are the contents, and they populate this nav host fragment. And there's lots of benefits to this model. First of all, you've got a single graph. Basically, you can visualize all of your navigation, which is a lot easier than trying to deal with multiple graphs that aren't aware of each other. It makes it really easy to manage property and view animations when using an action to move from one destination to another. And then finally, these activity view models can be shared among fragments, and that allows you to, have state information that's really easily shared between a whole bunch of different fragments. So there's a lot of things that fall out of this. Depends on your application architecture, but I kind of like the idea of having some activity view models and then fragment view models and using them together. It's useful to hold state like if users logged in or something like that. You don't have to put it in some generic place. I should probably pay attention to that. Next, you might be wondering, whether you should be navigating using destinations or actions. I kind of hinted at this earlier. So it is possible to have a graph that contains no errors. It's kind of nice to see these associations, though. I mean, that's really what we're trying to go for, is that when someone's actually looking at your nav graph, it's really cool to say that's the only way to get from there to there. We can't actually get to these other screens. So I definitely encourage you to actually use actions if you're using these things. It also means that when you're using actions, you actually get access to all this additional stuff. So you can actually apply your navigation, your animations. You can apply argument passing, backstack manipulation, and all of that is actually just contained within the graph. So the goal of these things, again, is take all of this navigation boilerplate and shove it into the graph rather than actually shoving it into other places in your application. And then finally, the other thing that's cool, which is one of the things that I always struggled with when I was dealing with fragments, was actually figuring out how to pass arguments between fragments. And often the way you ended up doing that was to have something in your activity and implement an interface, or you might have, I don't know, there are a number of ways of doing it, all of which were kind of very boilerplatey and heavy. And so we have this thing called safe args that actually allows you to very, very easily you do argument passing. And what are they exactly? Well, this is a code generation plugin. I apologize. But it helps read your code of some capacitors at compile time, and it also eliminates a lot of the boilerplate involved with passing arguments into your fragment. So as many of you know, all of you know, Android IDs are used to represent like tons of different things. And this is slightly problematic because it doesn't actually it actually leads to a problem. You can name things to try to make things better, but you could actually try to navigate to an image view, and that's fine. Nothing will complain about this, and you'll end up getting this completely illegible error. So without save args, you just navigate using the ID of an action, and you can actually end up with the same problem. But with save args, you actually use these generated directions classes, and that means you not only know that you're navigating to an action, but it's really clear that where this actual action is associated with it. That this is an action that comes from this fragment and goes somewhere else. And probably the coolest thing about this, and that's where safe args comes in, is that if the destination is an argument, you just set the argument right in the action. And my favorite part about this is that if it actually requires that argument, if it doesn't have a default value, then it actually requires you to put it in the constructor. So this means that so once you've said that this destination requires this argument, once you're using safe args and once you're using all of this stuff, that means that you will end up literally not ever being in a position where you're going to navigate somewhere where you forget to put an argument in. And then once we're back into the fragment, we actually use the from bundle method to get a nice version of that, and then we just use the arguments. So it's pretty straightforward, and it will hopefully solve lots of problems. Now, it is a plugin, so it means you have to shove it into your project build Gradle file and your app build Gradle file. And after you're done with that, you just get these generated files that contain all of these actions for any destination that has arguments. All right. So like Safe Args, this navigation UI, which I kind of mentioned earlier, is kind of a value add for the navigation component. It helps to ensure a lot of consistency and eliminates a bunch of navigation boilerplate. So it helps leverage the existing navigation controls that Android has, from handling the up button in the toolbar to putting navigation drawers in and handling the overflow menu, as well as things like bottom nav. So it's actually really nice in the sense that what you're trying to do again is make things consistent, eliminate a whole bunch of extra code, and that's where this was going. So it actually implements the material recommendations around this control, which might not actually be what you want, but for a navigation drawer, that means each one of these items is what we call a top-level destination. And what that means is well, let's say Gmail was using this scheme. The primary inbox might be the start destination, and every other destination in its sibling. And that would mean that the navigation drawer or hamburger menu, whatever you want to call it, would only appear on the start destination, which would make the navigation drawer a bit more hidden when viewing other destinations, but it would make the start destination far more clear. Now, note, this may be changing, because a lot of people have asked for this to be a little bit more flexible. But today, if you're viewing the starred folder, our backstack would consist of the starred messages in the start destination, which would be the primary folder. And then viewing the message detail would also add it to the backstack as well. Now, if we were to slide out the backstack and switch to the important folder, it would actually pop the message detail, pop the starred folder, and push the important folder fragment onto the backstack. So the idea is it is only keeping the current destination and the start destination on the backstack at any given time. And the bottom navigation menu currently works the same way. So once again, we can see it can contain views that are either start destinations or siblings of the start destination. So when the title screen is selected, it's only on the backstack, because it's the start destination. And when the rules screen is selected, in this case, then our backstack would look like that, start destination, rule screen. And when the about screen is selected, it looks the same way. So that's, again, it's always maintaining this same stack size, because these are start destinations. Now, this may not be actually how you want your bottom nav to work. In fact, even the material guidelines are unclear on exactly how this should work. So there are different ways to implement this. The beautiful thing about all of the navigation UI is it is just a helper. It is using public methods inside of the navigation controller. And so if you don't like the way this works, you are welcome to go and implement something else yourself. There's actually not a lot of code in it. So what about using these two things together? Well, they're really supposed to do the same thing. The bottom nav and the nav drawer actually are both taking you to kind of starting destinations, and they both indicate kind of where you are in the hierarchy. So using them together is a little bit, it provides some cognitive dissonance to your user, because you can't display the destination you're on unless they're the same, in which case, why do you have both? However, here's an app that has not been very successful, that actually tries to use both patterns together. So if you feel like you really need this for your own application, you can actually do that. This basically works by not showing that bottom menu, the bottom nav, when showing the hamburger menu, et cetera. And you can actually implement something similar to that by using nested navigation hosts that have different graphs. So you've got the outer navigation host fragment that contains the bottom nav control, and that operates on the inner navigation host fragment. But honestly, I would avoid doing this, because it's pretty complicated for users, and it doesn't necessarily lead to a successful application. Another question people often ask about navigation is tabs. Why are they not supported by the navigation library? And that's because in Android, these top tabs are actually not intended to move to a due destination. They simply move to a different view of the same thing, and they don't get put on the backstack. So there's really no reason for navigation to support them. So if you want to know why, that is the reason why. Now, all of these things are based, the bottom nav, the navigation drawer, and the overflow menu are all always based on menu resources. And the way you tell navigation you want to use the menu item to navigate to a destination is you simply set the menu item to the same ID as the destination. So it's really, really straightforward. After you created the menu resource, you inflate it as you normally would for an overflow menu or an action bar. In the onCreate options menu callback, and then on options item callback, you actually check to see if the item has been handled by the navigation controller by calling on nav destination selected. And this also makes it really easy if you want to mix things, like some things you might want to have navigate. It turns out people want to do other stuff with menu items, so it's very easy to flexibly use those together. You can set up bottom navigation in the activity with a single call to set up with nav controller. And to handle the up button on a fragment, you can call setup with nav controller. Again, these are just all very simple. You actually don't even need the on navigate up call. So if you want to actually have a toolbar that looks like an action bar that's sitting in your fragment, which might be useful if you're going from a multi-activity pattern to a multiple fragment single activity pattern, you can just do this, and you end up getting the exact behavior you want. Now, in the action bar, you also have to do a little bit more because you have to also handle this on support navigate up in addition to the setup action bar with nav controller and on create. Almost done with these. Adding a navigation drawer to the existing action bar involves adding this drawer layout to the existing action bar with nav controller and navigate up functions, as well as adding this additional setup with nav controller on the nav view associated with it. And what's great about all these, as I kind of said before, is all these are just UI helpers, and they're all written against the public interface that is used for navigation. You can change the behavior if you want to, but I think the key thing here is they're all trying to follow those principles of navigation that I talked about earlier. So inside of this callback, which is inside of the library, you can see that on nav destination is selected, and it's called with true. And yes, I'm kind of contradicting myself because this is really not a public interface. But it actually uses the public interface. So it's just an extra helper function that actually does this. All it actually does is pop up to the start destination before adding a new destination. There's really no magic here. It's just trying to follow these principles that I was talking about earlier. So one of the most common heard pieces of feedback when we released this, and I think I had at least 10 developers come up to me and say, so how do I do shared element transitions? And the good news is, well, actually, back then you couldn't. But the good news is with Alpha 6, we actually added the ability to support shared element transitions like this. And it's actually pretty easy to add them in. So from a navigation perspective, this is really the only new part. We create extras to map the view we're going to share to the transition name. And you've done all this before. Then you can also pass these extras in when you actually do the navigation. And the good news is that's all you have to do differently from the navigation part. The bad news is that it actually doesn't make this any easier than using shared element. How many people actually played with shared element transitions? I assume almost everybody, right? Yeah. So it doesn't actually help you make them work. You still need to create transition sets. You still need to wait for layouts to happen. You still need to wait for images to be loaded from the internet, all that kind of stuff. Here's an example of what I did to do that with a binding adapter with Glide. You might consider this a horrible hack, but at least it was a kind of nice way of saying, okay, well, I've got one image that I'm waiting for. I can just create this adapter. So now we understand navigation principles. We know about navigation and navigation UI. Let's talk a little bit about conditional navigation and how to include logic for navigation decisions. And there's some cool stuff you can do there. So one of the things you might need is a login flow, and because let's say you're logging in with something like Firebase login, where you can get told at any time that that account is no longer logged in, you probably want some way to store that state and to be able to actually conditionally navigate. So you've got a bunch of fragments. Let's say most of these aren't available unless you're logged in. We also have this login flow, and what we want to have happen if the user ends up ever navigating to one of these screens when they're not logged in, we want to automatically redirect them to the login flow. So stated this again, if you're logged in or if your logged in state changes, we'd like to have some logic to check to see to make sure you're redirected. So the first thing we're actually using here is a nested navigation graph for our login flow. And that's kind of nice because these nested graphs actually just contain a series of destinations. You just select a whole bunch of them, right-click, and you can create a graph, and it looks like this. And by definition, you actually don't navigate inside your graph. You actually navigate to the start destination of your graph, and now you're in a completely separate little graph that is doing its own thing, which is really useful for something like login. And we can use something called a global action now to get to this flow. So remember I talked about actions, they're connecting destinations. Well, it turns out you can also create a global action that allows you to connect any destination to something else. And that's still useful because you still end up getting the ability of having like safe args. It just doesn't make it really clear in terms of how that works in your graph. And global actions can be used by any destination. And basically, it's any action in your code that's not nested within a destination. So here's what our graph without that login flow ends up looking like. And here is the nested login graph. So that blur there actually represents the outer navigation graph nested within the outer navigation graph. And then we have our global action here, which uses the ID of the nested login graph as its destination. Now, the on-navigated listener is called whenever you arrive on a destination, and it includes the current destination when it's triggered. And it's used internally for updating the state of navigation UI components, like the bottom nav. So whenever you change a destination, the bottom nav actually updates automatically. And this is done by actually using one of these listeners. And as a note, you should probably remove the listener also. And so here's what that code looks like. You can add this navigation listener in your activity, let's say, and it's triggered whenever the controller changes destination. And you can use this to see whether the destination requires login and then redirect navigation here. So this is good if you're in the middle of navigation, want to make sure you never end up in a place where you are not logged in. And finally, let's talk about the navigation within the flow itself. So let's say we let users sign up, and there's a bunch of intermediate screens for that. And we finish sign up, you want them to go all the way back to the starting login screen. And to do that, you can use the pop-up to attribute in the graph itself. So here on the action, when you finish login, it removes everything on the backstack up to, but not including the login fragment. So what this means is that any or all of these intermediate destinations will actually be popped off the backstack. So finally, I want it so when I finish login, I pop the entire graph off the backstack and go wherever I was before. And you can actually create a global action within your login graph for this. And this will pop the entire nav graph off the backstack. And by saying go back to nav graph start destination, which is login, and pop that inclusively. So that's a little bit about how to deal with conditional navigation and maybe this login flow, which is, again, kind of painful. Deep linking is something that actually navigation makes a lot easier, especially if you are have ever had the problem of wanting to deep link into an app and get into a specific fragment. This is a problem that is completely solved. So this is the kind of link that you might use in the case when you would need a pending intent, so just for a notification. So creating a deep link pending intent involves using the nav deep link builder with the navigation graph and the destination and the pending intent. So pretty straightforward. Now, if the graph is a simple one like this, with a start destination and sibling destinations, the backstack from the deep link will look something like this, with the start destination and the selected destination on the backstack. Now, if we put that entire thing in this case, into a nested graph, then the backstack would actually be generated with the start destination from the main graph, the nested graph, and the selected destination. And you can also create deep links that can be executed easily from the web or from other apps. So we can create that deep link right in the navigation editor. Trust me, that is actually a URL. And this creates a deep link tag in the XML. Since the fragment we're deep linking into requires an argument, we need to put the argument in curly braces as part of the deep link URL path. And you also need to add the correct intent filters into the manifest. And fortunately, we automate this because you can just literally add the nav graph tag with the navigation graph ID, and it will automatically generate all the correct intent filters automatically. All right, so now we've talked a little bit about how deep links work, and that's kind of useful because it's actually how one can actually implement instant apps inside of navigation. So, as you know what instant apps are, they're Android experiences that require no installation. How many here have actually experimented with building an instant app, just for my own? All right, like 8 of you, that's great. You can only, basically, what's great is it only downloads the modules that you actually need, not the entire app, which is great for your users. And this means that your app structure ultimately ends up being multi-module. So for instant apps, you'll always have an installable module and a base module and different feature modules. So when working with navigation, you add a unique nav graph for each feature module, including the base. And these do not directly reference each other. Then the installable and base modules will have additional nav graphs with the exact same name for overriding purposes. The main nav graph for the installable app ends up looking like this. Now, it contains all of the feature nav graphs because when you're using the installable app, you actually do download all of the modules. And then the base nav graph would look like this, which is what you'll be using in the instant apps case. Now, note that this contains the activity destination. Unlike normal activity destinations, this destination is an implicit activity deep link because it includes a URI instead of a destination ID. And in an installable world, if you want to navigate from the base to a feature, we actually start off in the base nav graph. And here's an action, there's always an action bar adest. And the main graph XML uses nav graph A, which ultimately has adest in its start destination. So when you navigate to adest in the installable app, you're navigating here. Now, if you're in the instant app, your code, what's great about this is that your code inside of your application actually remains the same. So it doesn't actually realize that it's working in a completely different way. So you still have this action saying to navigate to adest. That's all your code has to do. But in the nav graph, you actually change this to trigger that implicit activity deep link, going to the deep link in this URI. And in nav graph A, this fragment that has the deep link, it's actually the same as the start destination fragment, so they go to the same place. And if you want to navigate between features, you do something similar. So here I've got this like deep link destination with this URI in nav graph B, and in nav graph A, I've got one of those implicit activity deep links. All right, so I know that was a lot. And I was talking really fast, I apologize. But there is lots of actual information available here on the web for you to go and find out more about how to do all of this. I think, and I think what's also exciting, if you actually got to watch Wojtek's talk earlier about app bundles, is that it's actually going to simplify making instant apps and apps with dynamic features with nav graph. And I think there's going to be more on that coming up relatively soon. But again, to get started, we've got documentation, we've got this useful code lab, we've got a bunch of samples. We've actually put it into not only our prime sample for architecture components, which is our GitHub sample, but also into the Sunflower sample, which is great and a little bit more, a little bit simpler and more understandable. And with that, thank you very much. I think we have a little bit of time for questions.